One final note as we finish up chapter 21, talking about absolute entropies, is the most important use of absolute entropies is to calculate entropy changes for a reaction. And that's why we go to all the trouble of finding these absolute entropies, is so we can understand what's happening in terms of enthalpies of reaction. And the way we do this is very similar to the way we do it for enthalpies or things like that. One thing here is that we don't need to think about are things in their standard states or whatever. We can just look up absolute entropies and just the difference in entropy. You add up the entropies on the left on your products on the right-hand side, and then you subtract all the entropies from your reactants that you started with. So the enthalpy change for the reaction is very easy to calculate. You just add up all of the standard molar entropies of your products. And of course, since you're looking at molar values, you need to multiply by the stoichiometric coefficients. Just like you do for enthalpy. And then you subtract the sum of all the absolute entropies of your reactants. Again, with the stoichiometric coefficients added in. And this can tell you overall what's going to be the entropy change for your reaction. As long as you can find these absolute entropy values, looking them up in a thermodynamic table at the temperatures that you're considering. So we'll just do a quick example of this. Right. So if we look at the reaction of hydrogen and chlorine, hopefully you never have to deal with this reaction because it involves chlorine and hydrogen to make hydrochloric acid. This is just a fun reaction all around because we're making acid out of two deadly substances. Hydrogen is only deadly in the fact that it can blow up. But anyway, to find the entropy for this reaction, we need the absolute entropy of HCl minus 1/2 times the absolute entropy of Cl2 gas. And we do need the correct phases here. Plus 1/2 times the absolute entropy of H2 gas. Right, and we don't have to remember that H2 and Cl2 are like standard forms, and so therefore they're zero. They're not zero, right? You just look up the value in the table and you can do this. So the values here, so this is delta S R naught for the reaction. The values here, if we look them up, are 186.9 joules per mole Kelvin minus 1/2 times 130.7 joules per mole Kelvin plus 1/2 times 223.1 joules per mole Kelvin. I just noticed in my notes I have these backwards. So this one is chlorine because it's heavier. This one is hydrogen. Otherwise, these don't really make sense because hydrogen should have the smaller entropy as a much lighter molecule. So if we go ahead and do that, all of this works out to be positive 10 joules per mole Kelvin. All right, and so that's an example of how we can find the entropy change for a reaction, which is really one of the most useful things for this because that allows you to also calculate further thermodynamic properties. And that's it for chapter 21.